Hi, this is Nesniewski. We're doing discrete structures. This is section 4.2, mathematical induction. We're doing the homework problems. I made a change. We were supposed to do in the list, it said 7b. I don't want to do that problem. It's not the type of problem we're going to do. Okay. In class, I think we did 5 problems. The book does another 5 problems. We're going to do another 1, 2, 3, 4, 5, 6 problems. The point is, a lot of the problems are the same, and a lot of the problems we see little variations, but I want you to see, you're going to see altogether 5, 6, you're going to see like 17 problems. So that's good, okay? And I tried to do it to show you that they're all basically the same, okay? So it's basically a 3-step process, 4-step process. Do the base case, show what your assumption is, show what you want to do, what you want to get, okay? So that's the k plus 1, and then actually do it. So let's do it, okay? So the base case. So let's do this. 4a, show that n to the third minus n is a multiple of 6 for all n member of p, positive numbers, okay? So first the base case. Again, it's always the same thing. So for the base case, so this is when n is equal to 1. So we have n to the third minus n. Okay, so that's 1 to the third minus 1, which is equal to 0. 0 is a multiple of 6. 6 times 0 is 0. So yes, it works for the base case. You should try it also for n is equal to 2. Let's see what we get. 2 to the third power is 8 minus 2 is 6. So 2 to the third minus 2 is equal to 6. That's definitely a multiple of 6. Let's just do it for 3. 3 to the third is 3 times 3 is 9 times 3 is 27 minus 3 to the third minus 3. 27 minus 3 is 24. 24 is a multiple of 6. So far it works. Okay, this again you don't have to do. Great. Assume k, now we're doing it for k, we're going to try to do it for k plus 1. Assume k to the third minus k is divisible by 6. To show, this is the next step, to show k plus 1 to the third minus k plus 1 is divisible by 6. Okay, so step 1 is this, write the base case. Step 2, write the assumption. Step 3, show what you want to get. That's your cheat sheet. And now, step 4, you actually do it. Okay, great. I'm going to do exactly like I did in the class, talk about writing the new in terms of the old. So let's do it. So k plus 1 to the third minus k plus 1. This is the new. Okay? Okay, so this is the new. So we want to write it in terms of the old. So the first thing we want to do is we want to multiply this out. Okay, we want to multiply this out because somewhere in there we want this old. Okay, so let's multiply it out. So this is equal to, let's see, k plus 1 times k, well, let's write it, k plus 1 times k plus 1 times k plus 1 minus k plus 1. Okay, so let's multiply this. This is k plus, this is k squared, this is just FOIL. K squared plus 2k plus 1, multiply that by k plus 1 minus k plus 1. Okay, let's multiply this out. This becomes k to the third plus 2k squared plus k. That's k times all of these, plus k squared plus 2k plus 1 minus k minus 1. Okay, I brought the minus inside. Okay, great. So this is equal to k to the third. Now we combine like terms. 2k squared plus k is plus 3k squared plus k plus 2k is plus 3k plus 1 minus k minus 1. Okay, this is going to cancel out with that, and this will cancel out with one of these. So now you have k to the third plus 3k squared plus 2k. That's it. Plus 2k. Okay, I would like to write this in terms of the old. So this is the new, and we rewrote the new. But I would like to write it in terms of this. So I want to write it like this. This is equal to k to the third minus k. That's exactly what we assumed is divisible by 7. Okay, so this is the old. So we write the new is equal to the old. Okay, but we have to get this thing in. Okay, so what we just subtracted a k out of nowhere. So we have to add in a k. So let's add in 4k. Oh, I'm sorry. Plus 3k squared. Okay. Plus 3k. Why 3k? Because I did a subtraction of k here. I put that in by myself. So if I add 3k here, 3k plus minus k is plus 2k. So this is the fix. Okay. Now again, this is why we do 17 problems like this, because you wouldn't have seen this beforehand. Okay. Great. Okay. Let's just keep focus on what we want to do. We want to show this is divisible by 6. We know this is divisible by 6. It would be nice to show that this is divisible by 6. Right? Let's go through that again. We want to show this is divisible by 6. This is equal to this. We know this is divisible by 6. We'd like to show that this is divisible by 6. Okay? So I'm going to rewrite this. I'm just going to write it right over here. Ready? This is equal to k to the third minus k. And now I'm going to pull out 3k from both of them. So this is the old. We know that's divisible by 6. Plus 3k times k plus 1. I pulled out a k, so I have a k over here, plus 1. Okay, great. Notice what we have here. This is k times k plus 1. One of these is going to be even. K plus 1, one of them is even. Take any two numbers, one after the other, one of them is even. Okay, so what do we got? An even number times 3 is divisible by 6. So one of these is even, times 3 is divisible by 6. So this old, we assumed is divisible by 6. This is 3 times 2 times something, x, because one of those is even. So this is 3 times 2 is 6, is divisible by 6, so divisible by 6. Conclusion, when you add two things that are divisible by 6, you get something that's divisible by 6. So, conclusion, this is divisible by 6. Let's go through that again. The new is equal to k plus 1. We want to show it. What we did was we wrote it out. We just broke it all out, combined like terms, etc. Then we took what it's equal to, and we wanted to write it in terms of the old. You always want to write the new in terms of the old. That's the thing about the dominoes knocking one over. If you can knock over the old domino, then you can knock over the new domino. So you get that. Anyways, but we had to fix it. Then, once we saw that we had to fix it, we had to see this is divisible by 6. We had to show that this is divisible by 6, and that was a little trick. Okay, that's good. Let's do number 8. Okay, most of these are the same format, just a lot of ugly math. Can't take it away. Okay, we're gonna need some more room here. Okay, so let's do number 8. number 8. Okay, so we want 8. Prove one over 1 times 5 plus 1 over 5 times 9 plus 1 over 9 times 13 plus plus 1 over 4n minus 3 times 4n minus 3, 4n plus 1. All that's going to equal to n over 4n plus 1. Okay? Totally not pleasant. Okay? Not intuitive. I have no intuition of why this is true. With the Gauss trick, we saw how it's true, but here we don't. Let's just do this. So this is another way of stating it, in terms of this, is the sum. We're adding up things from I equal one to n. Let's just make sure that's true. 4 times 1 is 4, minus 3 is 1. 4 times 1 is 4, plus 1 is 5. This is 4 times 2 is 8, minus 3 is 5. 4 times 2 is 8 plus 1. Okay, so this is 8 plus 1, and this is 4 times. This is 4 times 3 plus 1. 4 times 3 is 12 plus 1. So this works. Okay, so I is equal to 1 to n of 1 over 4i minus 3 times 4i plus 3. But we want to finish where n, so we're going to plug in the n. And we're going to say that this is equal to n divided by 4n plus 1. Okay, let's do the base case. Base case, n equals 1, so let's see what that's equal to. We only have one term to add. We already have that term. So question is 1 times 1 over 5. Question, is that equal to, let's plug 1 in here, 1 over 4 times 1 plus 1. 4 times 1 is 4, plus 1 is 5. Is 1 over 5. Is 1 over 5. It works. Yes. The base case is simple. Good. I need more room, so I'm going to erase the base case because we don't need it. We showed it's true. Good. Now, let's assume, okay, the sum from I equal 1 to k of 1 over 4i minus 3 times 4i plus 3, okay, is equal to, now I plug in, instead of n, I plug in k, so this is going to be k times, divided by 4k plus 1. That's what I'm going to assume. To show, this is step 3. Step 1 is the base case, step 2 is show it to assume, step 3 is to show. To show that the sum of I equal 1 to k plus 1 of 1 over 4i minus 3 times 4i plus 3 equals, okay, k plus 1, I'm going to plug in k plus 1 here, okay, divided by, I'm going to write this as 4k plus 1, so it's 4k plus 4 plus 5. Okay, that's going to be our cheat sheet. Okay, I plugged in k plus 1 here, so that becomes 4 times k plus 1 is 4k, plus 4 plus 1 is 5. Great. Next, let's actually show it. The sum of I equal 1 to k plus 1 of 1 over 4i minus 3 times 4i plus 3, okay, equals, this is, now we're actually showing it, this is the new, okay, and I'm going to write it. Look, if you want to add up all the numbers from 1 to k plus 1 of a certain type, then that's the same thing as adding up all the numbers from 1 to k and then putting in the last one. So let's put it in the other one. So this is the sum of I equal 1 to k of 1 over 4i minus 3 times 4i plus 3, okay, plus, so this is the old, so we're writing the new in terms of the old plus a fix. What's the fix? Well, I'm going to put in the last term here. The last term here is when I is equal to k, but I want to go till k plus 1, so I have to put in the last term by hand. This is, for computer scientists, this is no problem. If you have a loop doing 36 things in the loop, doing the loop 36 times, it's the same thing as doing the loop 35 times and then manually afterwards doing it one more time. So that's what we're doing now. We're manually putting it in one more time. So this becomes 1 over, plugging in k plus 1 here, 4. I'm going to do it. K plus 1 is 4k plus 1 minus 3. So that's 4 minus 3. You know what? We're going to get in trouble. So let's do it slowly. 4k plus 1 minus 3 times, this is going to be 4k plus 1 plus 1. Okay, so this is the fix. Great. Now, let's write, we want to show this is true. So what we have to do is, we want to show that this is true. Hold on, we'll get there. So first, let's put in our assumption. What's our assumption? What did we assume about the old? Well, we assumed that this is equal to k over 4k plus 1. That's what we assumed. Now we do the fix. Okay, good. Plus, I'm going to just make that presentable. It's going to be a 1 on top, and it's going to be 4k plus 4 minus 1 minus 3. So it's going to be 4k plus 4 minus 3 is plus 1. Okay, that's good. Okay, what's this going to be? This is going to be 4k plus 4 plus 1 is 4k plus 5. Maybe I did this in class. Okay, great. Anyways, just remind you what our cheat sheet is. This is our cheat sheet. This is what our goal is. Okay, let's finish this off. We have a problem here. We want to add two fractions, but they don't have the same bottom. So make them have the same bottom. How do you make them have the same bottom? Well, this needs a 4k plus 5. Okay, well, but if you have the bottom have the 4k plus 5, the top also has to have a 4k plus 5. Okay, great. So now, let's see what we get. On the bottom, we have 4k plus 1 times 4k plus 5. Okay, and this becomes 4k squared plus 5k plus 1. Okay. Okay. Well, guess what this is equal to? I can just, I'm looking at my cheat sheet and I know what I want it to equal to. So I bet you this is 4k plus 1 times k plus 1. Now we have to check that. That was a good guess, but let's check it. Ready? 4k times k is 4k squared. 4k times 1 is 4k plus k is 5k. 1 times 1 is 1. Great. Ready? this cancels out with this. Okay, and I'm left with k plus 1 over 4k plus 5. I might have done this in class, I don't remember. Okay, so that's 8. Good. I think I did this in class, I apologize. Get to see it again. Good, sorry. Let's do number 14. Okay, so let me just cancel that out. I'll find something else to do instead. Well, 14 is new. Okay. Okay, so I'm not going to erase it from the video, but I won't. I did that in class. So let's do 14. 14 is as follows: prove that n squared is greater than n plus 1. N squared is greater than n plus 1 for what? For n greater than 2. For n greater than or equal to 2. Okay, well, let's do the base case. This is actually easier. Base case, so what do we have? 2 squared is greater than 2 plus 1. Is that true? And the answer is yes. This is 4 is greater than 3. Yes, it's true. Done. Okay, good. Now, assume k squared is greater than k plus 1. To show k plus 1 squared is greater than k plus 2. Well, let me write that better. K plus 1 plus 1. That's k plus 2. Okay? So that's equal to k plus 2. So we want to show this is greater than that. Great. Now we actually show it. Step 1, step 2, step 3 to show. So let's do it. K plus 1 squared, that's the new. We write it in terms of the old. So let's multiply it out. This is equal to k squared plus 2k plus 1. Okay. Okay. Now, this is the old. Okay, great. So, this we know, close this off, we know that this is greater than k plus 1. Okay, so this is greater than k plus 1. So now add what I closed over. If this is bigger than this, then if you're going to add this, you can add it on the other side too. 2k plus 1. Okay. Let's see what this is equal to. This is equal to k plus 1 plus 2k plus 1. Don't move, don't move. Okay, my goal is to show that k plus 1 is squared is bigger than k plus 2. That's k plus 1 squared. Okay, question. So this is equal to 3k plus 2. I'm a little bit confused. This is very easy. This is, look what we want. this is equal to 2k plus, I'm sorry, 3k plus 2 is equal to k plus 2 plus 2k. Okay? Now look what we have. K plus 2 plus 2k. That's just another way of writing that. K plus 2 plus 2k is 3k plus 2. Very good. But this is more than k plus 2. Okay? Which is exactly what we wanted to show. K plus 1 squared is more than k plus 2. K plus 1 squared is this. This is more than this. This is another way. Now we just combined like terms like this. And now I looked at my cheat sheet. This is my cheat sheet. I saw k plus 2. Okay, k plus 2 is in there. Okay, so this was our assumption. So now this thing is more than this thing. But 1 second, it's got some extra things. Well, 2k is more than 0. This is more than 0. So take this, add something more than 0, and you get it's more than k plus 2. You added something more, so it's more than k. So let's say this is 15 plus 2k. Take out the 2k, it's more than that. The main point is k is more than 0, so 2k is more than 0, so you're adding more. Conclusion, this is more than 2k. Notice that even if k was 1, this would still be true. If k was 0, this would not be true. If k was 0, this would not be true. K plus 2 is not more than k plus 2 plus 0. K plus 2 plus 0 is not more than k plus 2. K has to be more than 1. Now you might say, we had k is more than 2. That's fine. We needed that for the base case. We don't need it for here. Main point. This we showed is equal to this, which is equal to this, which is more than k plus 2. This is what we wanted to show, and we showed it. Okay, good. Number 16. For which, okay, it's a funny question. For which n and p does the inequality 4n is less than or equal to n squared minus 7. N squared minus 7. Again, with all of these things, they give it to you. I will give you a problem. I won't ask you to make up a problem. They give you a problem. They know it's true. They just want to know when. Okay, so they're asking you when is this true. Let's just try a few values. Let's say n is equal to 10. Okay, so then we have 40 is less than or equal to 10 squared, which is 100, minus 7, which is 93. That is true. N is equal to 5. Let's see if that's true. This is going to be 20 is less than or equal to 25 minus 7. 25 minus 7 is 18. It's not true. Let's make sure we got that right. 4 times 5 is 20. 25 times 5 is 25. Minus 7 is 18. So it's not true. It's not true for 5. Great. We're going to worry about the base case in a few minutes. Okay? We're going to even leave room for it. But I want to do the induction. Assume 4 times k is less than or equal to k squared minus 7. Okay? To show, we're going to leave the base case. This is the base case. We're going to do that later. Step 1, step 2, to show 4 times k plus 1 is less than or equal to k plus 1 squared minus 7. Okay, that's what we wanted to show. Okay, I just want to work this out because we're going to need it. This is going to be k squared plus 2k plus 1 minus 7, This is going to equal to k squared plus 2k plus 1 minus 7 is minus 6. Okay, great. So let's look at this. 4k plus 1 is equal to 4, so this is the new, 4k plus 4, this is the old, okay. By assumption, this is less than or equal to k squared plus 4. If this is less than this, whoops, stop, k squared minus 7 plus 4. Let's go through that. By assumption, 4k is less than that, so I wrote 4k over here, plus the 4, this is less than this. So if this is less than this, then if you add 4 to both sides, you still have the inequality. Okay, great. Let's combine like terms. This is equal to k squared minus 7 plus 4 is minus 3. Okay. Now, thank God we have our cheat sheet here and we know what we want to get. Okay, so at the end, I'm going to want to get k squared plus 2k minus 6. I'm going to have an inequality here. Okay, how do I go from here to here? What do I have to add to this to get this? Okay. And the answer is plus, the k squared is there already, 2k minus 3. Let's just make sure. K squared, 2k plus 2k plus 2k. Minus 3 plus minus 3 is minus 6. Okay, so this is the fix. Okay, so what do I want? I want this to be less than or equal to this. Because I want this is less than this, which is less than this. This is what the ultimate thing I want to show. Okay, great. This is less than this. I want that less than. This is less than this. Great. Now, question. K squared minus 3 plus something is less than this. I'm sorry, it's equal to that. I just did it. I'm sorry, that's equal to this. No, it's equal. Okay. But what gives you the right to add 2k plus 3? You had this. This was equal. Okay? This was equal to this. Okay? What gives you the right to say that this is less than this? Okay? And the answer is because 2k minus 3 is more than 0. Look, I have this. This is k squared minus 3. That's equal. Now I'm going to add something to that. 2k minus 3 is more than 0. Okay? Why is this true? Well, k let's do this. K is more than or equal to 3 over 2. As long as k is more than 3 over 2, then this is in fact true. So, let's go through this. This is k squared minus 3. That's k squared minus 3. I added something to it. Why did I add this to it? Because I wanted it to equal to this. What did I add? I added 2k minus 3. You can't just add one side to the other unless this side is more than 0. Oh, it is more than 0 because k is more than 3 over 2. Okay, so that takes care of this. We have the old, we wrote it in terms of the new, we used the assumption of the old, okay? We fixed up our thing, we get k squared minus 3, okay? We wanted to get it to be this, we had to add something. We had to check that it's kosher to add this. The way to check that it's kosher to add is to make sure that this is more than 0. Well, let's see. First of all, is this true for 1? Now we go back to the base case. I don't think it's true for 1 because we need it bigger than 3 over 2, so it's not true for 1. So let's try. N is equal to 1. 4 times 1. Question, is that less than or equal to 1 squared minus 7? 1 squared minus 7. Is 4 less than negative 6? No, it's not. Okay, n is equal to 2. I'm going to tell you it's not going to work there either. Let's do this. This is 8 less than or equal to 4 minus 7. 4, this is 2. 4 minus 7, this is a negative number. 4 minus 7 is negative 3. No, it's not true. Okay, good. N is equal to 3 is not going to work. N is equal to 4 is not going to work. N is equal to 5 is not going to work. Let's try n is equal to 6. You ready? Let's try this. This is going to be 24. Is 24 less than 36 minus 7? 36 minus 7 is 29. Yes, it works for n is equal to 6. Hold on. We're going to come back here again. Okay? So, this is like that infinite line of dominoes. You know that every domino pushes over the next one, but you can't push the first one. You can't push the second one. You can't push the third one. You don't push the fourth one. You can't push the fifth one. Okay? But you can push the sixth one. Conclusion, it's true for all 6, 7, 8, 9, 10 we did. It's true for all of them. Okay? Main point here is as follows. Question, k squared minus 3. This is k squared minus 3. I want to make this to be more than it. So I add 2k minus 3. Who gives you the right to add 2k minus 3? Well, if k is more than 6, your base case, then 2k minus 3 is definitely more than 0. If k is more than 6, then 2k minus 3 is definitely more than 0. So you're definitely allowed to do it. You're allowed to do it for any k more than 3 over 2. But for 6 for sure, for 7 for sure. Let's do 6. 2 times 6 is 12, minus 3 is 9. K minus 3 plus 9, k minus 3 plus is definitely less than k minus 3 plus 9. So that works. Okay, that's what we wanted. Okay, that's number 16. Okay, great. Let's do number 18. We're up to number 18. Okay, 2n plus 1. Plus 2n plus 3 plus 2n plus 5 plus 4n minus 1 equals 3n squared. For all n in P, positive numbers. Okay, it tells you how to write it. Okay, it's a funny thing, but we're going to do it. I equals n to 2n minus 1 of 2I plus 1. Okay? Now, main point, we're not starting at 1, so we're going to have to do some fixing here. It's going to be nice, but I know how to do it, but it's not easy. Okay, so let's do the base case. This is just ugly math. There's nothing new. There's no new idea here. Base case. Okay? So, plug this in. For I equal 1 to 2n minus 1. So, the sum of I equal 1 to 2 times 1 minus 1 of 2 times I plus 1. Okay. So this is equal to, by the way, 2 times 1 minus 1 is 1. 2 times 1 minus 1 is 1. So this is all equal to 2 times 1 plus 1, which is 3. Now, what is this supposed to equal to? That. Question, is this equal to 3 times 1 squared? And the answer is yes, it works. Base case works. Okay, good. That's the easy part. Okay, good. Next, let's assume, I'm going to write the assumption here. Assume the sum from I equal k to 2k minus 1 of 2I plus 1 is equal to 3k squared. Stop. That's the assumption. Okay, we did the base case, now we did the assumption. Great. To show the sum from I equal k plus 1 to 2k plus 1 minus 1 of 2I plus 1, the inside never changes. It's where we start and where we finish changes, but the inside never changes. This should equal to 3k squared, 3k plus 1 squared. Just for the hell of it, since this is our cheat sheet, we might as well work it out. So this becomes what? 3k squared plus 6k, that's the 3 on the outside times 2 over there, plus 3. Stop. That's our cheat sheet. We're going to circle our cheat sheet so that we can remember it, and this is what we're going to aim for. Great. Now let's show it. It's a little, well, you'll see it in a second. Okay, let's write it out. You ready? The sum of I equal k plus 1 to, I'm going to multiply this out. 2k plus 2 minus 1 is 2k plus 1. Let's just make sure we got that. 2k plus 2 minus 1. It's 2k plus 2 of, the inside stays the same, 2I plus 1. Good. Okay, that's the new. Okay, this is equal to, let's write it as the old. I want to leave me some space here. Then we're going to write that, and we're going to leave some space here. So this is nearly equal to, oh, I'm sorry, I need more space. That's equal to, let's write the old. The sum of I equal to k of 2k minus 1 of 2I plus 1. Okay, now this is the old. Okay, now that's not true. Okay, this is not true. This starts at k plus 1, this starts at k. This goes till 2k plus 1, this goes till 2k minus 1. Not true at all. Okay, so what we have to do is we have to manually add in what's missing. What's missing here and what's missing here. So let's go through this. This guy starts at k. He's leaving, we want to start at k plus 1. So I want to take out the kth guy. Look, I want to make this to be the same as this. Okay, he starts at k. He starts at k plus 1. I better subtract something. What should I subtract? I'm sorry, let's do this another way. I want to subtract the kth guy, so I'm going to subtract the kth guy. Minus. So he's going to go k, then he's going to do I is equal to k, then he's going to do I is equal to k plus 1, then he's going to do I is equal to k plus 2, then he's going to do I is equal to k plus 3, etc., etc. So I want to subtract something. What do I want to subtract? 2 times k plus 1. That's the kth term. I'm taking out the first term. So he's going to start at k, k plus 1, k plus 2, k plus 3, k plus 4, till 2k plus minus 1. Okay? I don't want him to do the kth term. I want to start at the k plus 1th term. Great. Next, he finishes, he's going to have 2k minus 1, 2k, 2k plus 1. He has 2 extra terms that are not in here. He has 1 extra term here, so I subtracted it. But he has 2 extra terms here that are not in here. So let's add them in, because I want to get this guy to equal to this. So again, let's see what happens here. He goes all the way till 2k minus 1. So I have to add in the next term, which is 2k. So 2 times 2k plus 1. Okay, and then I got to add in the 2k plus 1th term plus the 2 times 2k plus 1 plus 1. Okay, so now our boundaries are the same. Now with this is the fix. This is the fix. Our boundaries are the same. I'm sorry, I didn't need the space here. Okay, so let's go through this very, very carefully. Let's make sure we understand what happened here. Okay, he starts at k plus 1. He starts at k. Okay, I don't want the kth term. I want this. So I look at the old and I say, look, take out the kth term. That's exactly what I did here. A bunch of additions, but I take out the kth one. Good. Now, he finishes at 2k minus 1. He does 2 more. He does 2 more. I want to get this one, so I have to add in by hand the last 2 terms. That's exactly what I do here. I add in the 2kth term, which is here but not here, and I add in, it's missing here, so I have to add it in. And I add in the 2k plus 1th term, 2k plus 1th term. I is equal to 2k plus 1. I add it in here. Great. Now, I have this is equal to this minus this plus these 2 things is equal to that. That's a given. That's just a different way of writing it. I'm sorry, it's a little bit messy. Great. Now, let's do it. Let's do it. Let's use our assumption. This, what's our assumption? This is equal to 3k squared. That's our assumption. Now I'm going to fix up these little terms. So let's do it. Minus 2k minus 1 plus 4k plus 1 plus 4k, 2 times 2k is 4k, plus 4, oops, plus 1, plus 2, plus 2, plus 1. Combine like terms. Let's do it. By the way, keep an eye on the cheat sheet, because that's what we want in life. This is 3k squared minus 2k plus 4k plus 4k. 4k plus 4k is 8k, minus 2k is 6k. So that's 6k. Okay, minus 1 plus 1 plus 2 plus 1. So minus 1 and plus 1 is 0, plus 2 plus 1 plus 3. Bingo. Exactly what we wanted to show. Exactly what we wanted to show. So what did we show? We showed, this is what our goal was to show, and we showed that if you write the new in terms of the old, you still have to fix things so that you can write the new in terms of the old. You have to add in what's missing here, to get to there. You have to take out what's extra, which is the k plus the kth term, and you get it. But it works. Very nice. This is number 18. It's very nice. It makes sense. It's something new because we don't just start in the regular place. We start someplace else. We start at 2 different places. But once you see the trick, it's understandable. Great. Number 20. Okay, let's do number 20. Okay, 1 to the third, this is number 20. 1 to the third plus 2 to the third plus plus n to the third is equal to 1 plus 2 plus 3 plus n plus squared. So obviously when you square a lot of numbers, it's bigger than just doing that. But we want to do this. Great. We don't want to do it like that. We want to do it with symbols. So let's do it. It goes as follows. The sum of I equal 1 to n of n to the third. If you add up all the, of I to the third, okay, it's going to equal to the sum of I equal 1 to n of I, and then take this entire thing and square it. Okay? Not trivially true. It's not obvious what this is. But, let's get another pen, but it's true. So let's do it. First of all, it says it's true for all n and p. So let's do the base case. Base case. So let's do it. So we'll just do 1. So question is 1 to the third equal to 1 squared? And the answer is yes. They're both equal to 1. So yes, it works. It works for 1. Okay, great. Let's write the basic assumption. The assumption, okay, this is just to help you see it. We're really going to deal with this. The assumption is the sum of I equal 1 to k of I, each one to the third, is equal to the sum of I equal 1 to k of I squared. That's the assumption to show the assumption for the sum from I equal 1 to k plus 1 of I to the third is equal to the sum from I equal 1 to k plus 1 of I squared. That's what we're trying to show. Okay, You know what? Since this is our cheat sheet, could we use Gauss's trick over here? Let's get Gauss's trick over here. Because this is just adding all the numbers from 1 to n. Mr. Gauss taught us how to do that at the age of 5. So this is equal to, let's do it, k plus 1 times k plus 2 over 2 squared. Okay, that's Gauss's trick, and we're squaring it. Let's, for the hell of it, multiply it out. Again, if you want your cheat sheet, you better put it into the least complicated form. So let's do this. This becomes okay, let's multiply that out. This becomes k squared plus 3k, this is FOIL, k squared plus 2k plus 1k plus 2 divided by 2 squared. Not a very pretty sight. Okay, I don't want to multiply this out. We're probably going to have to multiply it out, but I don't remember. So let's do it. Okay, we have our assumption. We want to do this. So this is basically equal to the sum of I equal 1 to k plus 1 of I to the third. Okay, now we want to work it out and we want to see that it gets to that. So this is the hard part. Okay, so this is equal to, this is the new. I'm going to write the new in terms of the old. The sum of I equal 1 to k of I, the whole thing squared. Okay, great. Oh, 1 second. This goes till k plus 1. This goes till k, so we have to add something in. What do we have to add in? We have to add in the k plus 1 to the third term. K plus 1 to the third. You manually add in the last part. Great. Okay. Now, let's use our assumption. Let's use our assumption. We assume something about this. I didn't do it over here, but I'm going to do it. I'm going to do it now. We assumed messed up. Sorry. Okay. So I is equal to 1 to the third. Okay. Then you manually add in the last part. Great. Now we use the assumption. This is equal to, let's say this is the old, and now this is the fix. Okay, and so this becomes the sum of I equal 1 to k of I squared plus k plus 1 to the third. Okay, now I'm sorry, we should have done the Gauss trick here also. This really is what? This is k times k plus 1 over 2 squared plus k plus 1 to the third. Okay, let's multiply k plus 1 to the third. Oh, we have to write it out. K plus 1 times k plus 1 times k plus 1. Okay. Okay, so this is equal to, we're going to have to multiply this out too. So let's multiply everything out. I need a chair. Okay, this is a lot of work. Let's do it. Ready? So this becomes k squared plus k. I'm going to have to square that once, and we're going to get a 4 over there, plus, okay, this is going to be k squared plus 2k plus 1, all that multiplied by k plus 1. By the way, we know what we want in life. We know what we want in life. Okay, this all becomes, maybe I'm going too low. Okay, so let's do this on top. So this becomes, okay, let's just reserve our cheat sheet. That's what our goal is. Okay, let's do that. Okay, this is, again, there's absolutely no brains. We just have to show that when we multiply this all out, we're going to get that. So let's do this. This becomes k squared plus k times k squared plus k divided by 4 plus, let's multiply, we have to multiply this out. This is going to become k squared, k to the third, I'm doing FOIL here, but a big FOIL, plus 2k squared plus k squared. Now 1 times k is k squared plus 2k plus 1 times 1 is plus 1. Okay, hopefully that's going to equal to that. Okay, so this becomes what? K to the 4th. Good Lord. Well, we're going to have a k to the 4th over there. Plus k to the 3rd plus k to the 3rd, so it's plus 2k to the 3rd plus k squared. Plus, let's combine like terms. There's a k to the 3rd, 3k squared plus 3k squared plus 3k plus 1. Good Lord. Okay, let's continue. Oh, damn. I forgot to multiply by 4. I'm sorry, I want to multiply by 4. Put a 4 over here. This is a 4, so this is going to be, I'm multiplying by 4, so I'm put a 4 over here. Okay, so that's a 4. This is going to be, so this whole thing is divided by 4. This is going to be 2k squared plus, so this is going to be 4k, I'm sorry, this is going to be 8 plus 1. So that's going to be a 12k squared. And that's going to be 12k also. 2k plus 3 is 3k times 4 is 12k. And that's 1, it's going to be a 4. Okay, let's combine terms. This becomes divided by 4. We don't mind that because 2 squared on the bottom is going to be that. So it's going to be k to the 4th plus 2k to the 3rd, 6k to the 3rd, plus 13k squared, plus 12k plus 4. Okay, we got to do it. We got to do it. We just have to multiply this out and make sure that it's really equal to that. So let's do it. Again, there's nothing intelligent about this. This is just making sure that the math is right. So let's do this. I won't ask a question like this in the math on the test because it'll just take too long. So let's do this. K squared plus 3k plus 2 times k squared plus 3k plus 2. All this divided by 4. So let's see what this is equal to. Let's just multiply it out. This is k to the 4th. I'm going to do everything times this. Plus 3k to the 3rd plus 2k squared plus 3k to the 3rd plus 9k squared plus 6k plus, I'd be shocked if this actually works. Okay, so this is the first term, this is the second, 3, now we do this, 2k squared plus 6k plus 4. Hey, we like that 4. Okay, good. So this is this. Let's combine like terms. All this is divided by 4, by the way. Okay, so let's do it. K to the 4th. Great. 3k to the 3rd plus 3k to the 3rd. 6k to the 3rd plus 6k to the 3rd plus 2k squared plus 9k squared is 11k squared plus 2k squared is 13k squared. So far, oops, 13k squared. Next, plus, combine all the k's. 6k plus 6k is 12k plus 4. All this divided by 4. Our cheat sheet is what we get. So it worked out. What a pain in the neck. Doable, but a pain in the neck. Okay. Okay. Now, the main point about mathematical induction is if you do it, you have to do the base case, you have to write your assumption, you have to write what you want to prove, and then you actually do it. And you do it always, again, you want to show that the kth domino is going to knock over the k plus 1th domino. You do that by writing the k plus 1th in terms of the kth. Okay? Writing the new in terms of the old. Okay? Now it doesn't always go easy, but you have to fix it and you can do it. Okay, so that takes care of that. Thank you.